Hi, welcome you all for MCU series. In this video, we are going to write a bare metal program to handle a GPIO pin. By using that pin, I am going to make my LED to glow. In the previous video, we have seen how to open an empty project in STM32 Bare. We have created the project of A_1. In this project, we are going to write a bare metal programming inside the main function. By using this, by writing the code, I am going to blink the LED or make the LED to glow. So before handling a particular GPIO, we have some steps in order to make the particular pin as output. First one is we have to configure the peripheral clock. In which peripheral bus the peripheral is connected, we have to enable the clock of the particular bus. Later we have configured the peripheral clock. We have to select the GPIO pin, whether it is going to act as input, output or alternative function or analog mode. So that will be done by mode selection process. And third one is I am going to control the output. If I am configuring the particular GPIO as output means, then I have to give the value as 0 or 1 according to our use cases. So these are the 3 steps to make an LED to glow. And here I have listed some of the pointers value. One is assigned for peripheral clock, and next one is mode register, and third one is out register, which is nothing but first we are going to use peripheral clock means we must know what is the exact memory location of the peripheral clock. For that I have downloaded reference manual as well as the data sheet. Since I am using STM32F446RE, I have downloaded the data sheet as well as the reference manual. First we can go with the data sheet. I am using GPIO port A, which has inbuilt LED. So I'm using GPIO port A. So this is nothing but it is our block diagram of STM32F446. In this block diagram, I am going to use GPIO port A means we have to check this GPIO port A is connected to which bus. Here advanced high speed bus 1 is connected. My GPIO port is connected to this AHB1 bus. In order to use this particular port, first we have to enable the clock of this particular bus, then only my GPIO port will become active, else it will be in passive state. It won't have any signals or any power, we can say like that. So first we have to enable this AHB1 peripheral clock. Once we have enabled this clock of this particular bus, then GPIO port A will be available. Later on we can use the mode selection. So this is our reference manual. Inside the reference manual we have the memory bus architecture. In that I am going for memory organization. If you see here, memories are splitted like this. Like I am going to use any USB OTG means what will be the memory region allocated for that particular USB. If I am using GPIO port means which memory address is allocated for that particular GPIO port. So first we have to enable the peripheral clock. In order to enable the peripheral clock, we have to find the exact location of that particular register. So generally this peripheral clocks are present inside the RCC, reset and clock control. So what is the memory region of this RCC? It is starting from 0x4002 3800 to 0x4002 3BFF. So what is the starting address? The starting address is 0x4002 3800. So this is the starting address. So we know the starting address of RCC. Next I want to know exact register address of that particular AHB1 enabler. So in order to find that, I am going into the reset clock control. In that we are having RCC register. If we go along the RCC register, we have list of register, but which one we require is AHB1 enabler. So I am clicking this RCC AHB1 enabler. If you see here, this is the offset value. Okay, so you can look into the program. Here I have mentioned 0 cross 4002 3800, which is nothing but starting address of my RCC. But inside the RCC, multiple registers are there. In that, I particularly want to access AHB1 enabler. So in order to access that AHB1 enabler, we have to add the offset value to the starting address of RCC. So this is the starting address of RCC, and this is the offset value. By adding this, we can exactly attain the address of AHB1 enabler. So I found the AHB1 enabler register address. Next, I have found this address. Next, we want to find the address of mode selector. So to find the address of mode selector, we are going into our GPIO configuration. So I just minimize this reset clock. Before getting into that, I want to know what is the starting address of GPIO port A. Okay, to know the starting address of GPIO port A, we can go through this memory map GPIO, and what is the starting address? 0 cross 4002 0000. So I have included this. This is the starting address of my GPIO. Next, I want to know what is the offset value of the mode register. To find that, we are going into the reference value. Similar like RCC, we have GPIO general purpose input output. In that, we are having GPIO register. In the GPIO register, I am going to find the mode register's offset value. This is the mode register, and the offset value is 0 cross 00. So 0 cross 00, hence I have added 0 cross 00 to the starting address of GPIO. Okay. Then third address, this is the address of my GPIO mode registers. Next, I want to know the address of my out register. So to find the address of the out register, this is the ODR, output data register. The offset value is 0 cross 14. This comes in the GPIO port itself. So the starting address of GPIO is 0 cross 4002 0000 plus the offset value of our ODR register is 0 cross 14. So this denotes exact address of GPIO ODR register. So I have find the register address of the peripheral clock, mode register as well as the ODR register. Next, we can get into the logic. First, I want to enable the clock of GPIO A. So in order to enable the clock, we can get into the data sheet. Let me open the RCC. In RCC register, I want to enable this AHB1 enabler. Okay, you can see this register. It is a 32-bit register. It is starting from 0 bit to 31 bit. Okay, so I want to enable this GPIO A enabler. So in order to enable that, I want to set this particular port clock has to be enabled. So 0th bit has to be set as 1. If so, then my clock for GPIO port A will be enabled. So this is done here. I am enabling the 0th bit. This is the 0th bit, and which value I am going to assign? 1. And we already know if I want to set a bit. If you don't know, kindly go through the bit manipulation video which is in our channel itself. So in order to set the value, we have to do OR operation. If you want to clear the value, then we have to do AND with the tilt operation. So here I am going to do OR operation because I particularly want to set the last bit as 1. For an example, 32 bit means I want to set this particular bit as 1. So this is done by doing this particular step. So what I have done, I have enabled the clock for the GPIO port. So first step is over. Next one is we have to do the mode selection. Mode selection is nothing but again we can get into the reference manual. In this reference manual, mode selection usually done under the GPIO. So GPIO, we are having the GPIO mode. Here also the GPIO mode register is also a 32-bit register. It is starting from bit 0 to bit 31. But we already know that if you take any port 1 or port A, port B, port C of microcontroller, it usually have 16 pins. which is nothing but 0 to 15 pins will be available for each port. So since it is a 32-bit register, every 2 bits will be assigned for one particular port pin. For example, here it is my GPIO port A 0th pin, means this 2 bits will be used to select whether it is going to act as input, output or analog register. Similarly, this particular 2 bit will be used to assign the mode of my GPIO port A 15th pin. Okay, this is my 0th pin, this is my first pin, second pin. So totally 16 pins are there. So in this register 2 bits will be used to assign the or configure the mode of that particular register. For example, totally 2 bits are allocated for each pin, right? If I have written the value as 00, then the particular GPIO port A0 will act as input. If I am writing the value as 01, then it will be assigned as output pin. If I am writing the value as 10, then the particular pin will act for alternative function. I am going to use for analog movements, then I have to write the value as 11. Okay, so similarly, if I am going to handle the GPIO port A pin 0, means I have to write the first and 0th bit value according to my use case. I am going to use that input, means then I have to write it this place as 00, output means then this place has been written as 01. Okay, and we can get into the code. In this, we are going to blink the inbuilt LED of my Nucleo board. Inbuilt LED is usually connected with the port A 5th pin. Okay, I want to write port A 5th pin. Port A 5th pin, in the sense you can see here. This bit is for port A0, and this is for port A1, and this is for port A2, port A3, port A4, and this port A5. Okay, this one. So how many times I want to do left shift? If my value is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 times I want to do left shift. So only I am doing one left shift of 10. How many times I want to do left shift and which value I am going to do shifting? I am going to shift the 1 for 10 times. And here I have added one step, which is nothing but I am doing 10 times of left shift. That is 3 value is 0011. This value is left shifted for 10 times, which is nothing but by doing this step I'm ensured that this place is 00, or else I am clearing this exact 2 bits. Then only after clearing I am going to write the value as 01. I hope this is clear. Now what we have done, we have enabled or configured our port A 5th pin as output pin by doing this OR operation. This is for set and this is for clear. Before going to set, I make sure that I have cleared that particular 2 bit. Then I am going to write the value as 01, because 01 is the one which is used to configure my GPIO as output mode. So what are the steps that we have done? We have configured the clock for our GPIO port A. Then which pin I am going to use, I assign that particular mode, whether it is output or input. Here I am using it for output mode. Then the third one is I have make the particular pin as output. Then I want to give the value for the particular GPIO out as 0 or 1. How we are going to do that? For that we have loaded the address of my output data register. So output data register is also 32-bit register, but totally we are having 16 pins for particular port. So last 16 bits are reserved and first 16 bits will be used to write whether the value will be 1 or 0. If I want to make my port A 5th pin value as 0, I want to make my LED to glow, means I have to write this particular bit as 1. If I want to off the LED, means I have to write this particular bit as 0. It's so simple. So 5th bit, I am going to write the 5th bit as 1. I am doing OR operation. So exactly I have set the 5th bit as high. After I have done this changes, I am going to build the project. In order to build the project, here I have while of 1. Here I have some set of rules. This is nothing but to blink an LED. In this case, I am going to make my LED to glow only. We are not blinking that LED. So after you have written this piece of code, you have to right click over the project. Then you have build a project. So I am building my project. It is building. Should come up with 0 errors and 1 warnings. That's all about the building of the project. After we have built with 0 errors, means here you have the option in that we have to select run as. Then STM C++ application. Here I didn't connect my STM board. Once you have connected your STM board, you have to click this, then automatically this program will be flashed into our STM32. In the next video, let me run the same program in STM32 and I will show how will be the output. Thank you.